Hey, how's it going? Welcome to AngularAir. I'm your host, Justin Schwarzenberger, and today's episode, we are going to be talking predictive prefetching using machine learning and Guess.js, as well as some performance stuff within Angular, so it should be pretty cool. Let's kick it off. Say hi to our panelists today. Joining us, we've got Alyssa Nykel. Alyssa, how's it going?
Hey, glad to be here.
And we've got Mike Brocky with us. Mike, what's going on?
Not too much. Happy to be hanging out again.
Yeah, back from a little time off. It's nice to have you back.
Yeah, it's not the lighting in here. It's just a really good tan, a little dark.
Nice. Just imagine, if you're listening to the audio, imagine Mike Brocky with a nice golden tan. And our guest today, we got Minko Gechev with us. Minko, how's it going?
It's great.
It's great to have you back here.
Yeah, it's great to be back.
Yeah, always fun. Looking forward to you dropping a ton of knowledge on us today. We're pretty excited. Minko, why don't you give our viewers a little background on who you are for the ones that might not know?
Sure. So, I'm Minko, and I've been working on different Angular-related things. I was having a lot of fun contributing to the core at some point. After that, I worked on a tool for static analysis of Angular applications in order to enhance the tooling further. Did some work around the AngularJS style guide in the past, and I worked together with John Papa, Igor Minar, Warbel, and a few other folks on the new Angular style guides. And basically, I'm interested in Angular tooling, so that's what my focus is in my spare time. And in my full-time job, I'm working on an educational platform called Rime. It's rime.com. So that's pretty much it, a short overview.
Nice. Lots of stuff. My favorite too is for people that might not know, you're kind of the guiding force in Codalizer as well, right?
Oh yeah, that's one of the tools for static analysis that I've been working on, for kind of enforcing best practices from the style guide by statically analyzing your code and just suggesting fixes or doing fixes in some cases.
Yeah, so anytime we're using like an Angular CLI project in our IDEs or editors, we see these little notifications that tell us like this smarts about Angular and how we might be formatting stuff. Like that's driven by Codalizer magic. I love that. I get excited about that. Sorry. So I just wanted to mention that. All right. So we're talking all kinds of stuff on performance and stuff today, right?
Yeah. We can discuss, I guess, runtime performance, network performance, and a few cool things that we've been working on network performance together with the Chrome team and Gatsby and a few other folks.
Very nice. All right, well, should we get into it?
Yeah, I guess we can get started.
Yeah.
Oh, all right. Usually when I've been giving a lot of performance talks recently, and usually I'm focused mostly on runtime performance because, well, Mike and the rest of the Angular CLI team, they're doing so much in the Angular CLI side that there is not too much from our side, as consumers of the tool, to do in order to enhance our network performance even further. We have great build optimization there with the build optimizer, great minification. We have great bundle compression. Basically, we have everything right there. And in the end, for us, there is nothing much left. Well, except a couple of enhancements, such as lazy loading and analyzing our bundles to make sure that we don't have redundant dependencies. But that's something that we can take a look at a bit after. So with network performance, there are a few cool things, however, which are completely dependent on us. So in order to provide a nice application with fast runtime performance, for example, to not have sluggish typing in text boxes or to have instant rendering of the application right after it has been loaded, there are a few things that we can apply. But first, let me just clarify further the difference between runtime and the network performance. Basically, the network performance is the amount of time required for our application to get downloaded from the network. That's from the server. That's pretty much like the most simplified way to explain what's going on, because we need to download these assets from the server. So with the network performance, we're just making sure, enhancing network performance, we're just making sure that the resources get downloaded into the most efficient and fast manner. And with the runtime performance, when we already have our application rendered and we're interacting with it, we would want to make sure that the user has smooth interaction with the application. The main UI thread is capable of actually computing everything on time so that the browser can achieve 60 frames per second rendering. And yeah, that's what I was saying, that the Angular CLI team is doing already an amazing job in optimizing the bundles. We can do a little bit more. That's, I guess we can discuss afterwards. But the runtime performance is in our own hands.
Yeah, like you mentioned, I want to plug one of your talks, which is like probably one of my favorite talks of all time. I love it. Is your performance talk? Like you said, you've been given that recently about this runtime performance, right? And the things that we can do as Angular developers to enhance that and really be focused on that. And I think it's such a great talk that covers, you know, these little things that we can do, but it's really things that we can just get in the habit of the way we develop Angular apps, right? They're not complex things to do, but if we take them on, we can notice, keep ourselves out of these performance hits that we can easily get into, right?
Yeah. Yeah, thank you very much for this, actually. Really appreciate that you found the talk useful and you like the content.
Yeah, so that's, I think you have one from ngConf, one from a couple other places, right? That people can go watch, right?
Yeah, so on rhyme.com, we're going to start a free workshop for people who would want to go through the material hands-on. I did a couple of sessions, about 300 people took the session already, and I'm going to open it to basically to run constantly so anyone can log in and get a virtual machine and practice. That's going to happen probably in a couple of days.
So it'd be like a workshop you do online?
Yeah, a workshop I do online. Sometimes I'll not be there. But they'll be still able to see the video and practice in the virtual machines. And sometimes I will be there helping in the chat or over audio. So
that's cool.
We can have conversation.
Very cool. So that's a great resource for all this like kind of runtime type of stuff that they can learn and go and get that, right? So maybe we could dive into the what we're talking about with network performance and stuff, all this new fascinating stuff you've got going on with that, and like really what's the thinking behind, you know, like how do we approach that as Angular developers, going like is this a concern that we need to tackle? And then if we do, like how do we tackle that, right?
Yeah. I guess there are two big areas where we can do optimization. One of them is shrinking the bundle sizes, not only JavaScript, but also even CSS, and shrinking the amount of assets that we're transferring. And the second one is just reducing the network requests, or at least not performing them when the browser is doing the initial rendering or something critical, which can introduce additional slowdowns in the user interaction with the application. For example, extremely critical is to get very fast initial rendering of the application, because otherwise the conversion rate can drop dramatically. And Rob from the Angular team, he on 2 ngConfs ago, I think, he published, he shown a research from DoubleClick that it took about 19 seconds for the average web app to load over a 3G network. That's very sad. So I definitely think that I'll not convert as a user if it takes me that long to see what's going on the page. So that's extremely critical to optimize our network performance and to provide the assets to the browser that the browser needs to process and render after that. However, after the browser have downloaded all the assets, there is another thing which is from very critical importance. Some assets are more expensive than others. So we have images, which are great, and they're usually big, although we can apply some compression. There is a great book by Arius Manny actually called image.guide, I think. So you can take a look at it, how I'm going to actually apply it, I guess, as resources in the end of the podcast, so we can share it with everyone. And it explains in details how we can optimize our images. But images are still much cheaper compared to JavaScript, because after we download the same amount of JavaScript as an image, let's say 170K, that's another resource from Addy, where he explains the cost of JavaScript there. So it turns out that the images are about 25 times more expensive than images are 25 times cheaper compared to JavaScript. So JavaScript is 25 times more expensive. That's insane. And so the results. So I knew what was going on in the browser. You need to download the JavaScript. You need to process it because it's a programming language which the browser needs to execute. So it needs to go through all the standard phases, lexical syntax analysis, so on and so forth. And right after that, you need to execute this chunk of JavaScript. So, well, this introduces huge slowdowns. I think it's about 3 seconds to process 170K of JavaScript in the browser. And there are tools which help in the process. For example, Facebook released Prepack recently. Not too recently, maybe a year and a half ago already. And it is not a standard minifier or something that we're used to. It just takes our final bundle that Webpack has produced and evaluates this as part of the build process. So evaluates it as much as possible. So it can reduce the runtime, the initial runtime of the JavaScript after the browser downloads from the network. But still, there is that much that the tooling can do in this specific case.
It's kind of crazy. It's like building the build, right?
Yeah, yeah, very good point.
Yeah. Yeah, and like you mentioned, there's kind of like 2 avenues to that with the network performance, right? It's like that initial load, and initial delivery, which I think sometimes, I mean, I find myself as a developer when I'm working in my local environment, right? I mean, and especially with the concept that we're dealing with kind of like a single page app sort of scenario, which really kind of throws a wrench. I think if you've been developing for web for a long time and have used to server side rendering, stuff like that, and then in this single page app, you kind of get lost in the realization that like once that initial payload is delivered, then you have your app running and you have like data calls going, but not so much of loading of new pages, right? So you're almost in this kind of, I got my stuff, I got my JavaScript executed, I'm good now, right? It's fast. But that other avenue is the fact that then you may be lazy loading routes, getting more JavaScript in there, that sort of thing. And so it's really that twofold, right?
Yeah. Yeah, and unfortunately, there is no standard recipe that we can just follow and everything can work great. It's just there are different application-specific optimizations that we need to do, and all this we can do only with very careful profiling to see what's going on.
Interesting. And so kind of, I mean, the first thought is like, well, we as humans, as developers, right, have to do that. We have to think about that process, think about like, where do we want to optimize, right?
Yeah. The Angular CLI provides a great way to explore our bundles and look for redundant dependencies, right? We have Source Map Explorer as a tool which the CLI exposes. So that's great. So we can just pass our final production bundle or several bundles if we're using lazy loading, or we consider the vendor and the app bundle separately. And we can see what is actually being part of our bundle, and we can decide what we can basically exclude, which is the JavaScript which we are actually not using in our final application, and it has been, or we can just use more specific imports in order to, for example, if we're using Lodash, we can either import the entire Lodash, or we can import individual functions from it. Same, well, with Rx, things are a little bit different after the pipe operator, so now it's harder for us to shoot ourselves in the foot, but still, we can see what exactly is going on there.
So from that avenue, what we're trying to do, what you're explaining, what we're trying to do is say, here's all of the stuff that we've, built our application with. What can we first identify that's extra stuff that we just never called or never do throughout any of our application? Can we get rid of that stuff, right? And start with that.
Yeah.
With the source and explorer, stuff like that, right?
Yeah. And about the network performance also, we can look at it from 2 different perspectives, both, I guess, from how it impacts our business and how it impacts our users. Our business, well, first, our users, they're going to be frustrated, I guess, if the app is slow. So this is directly going to impact our business as well. It's going to reduce the conversion, the revenue, and everything. So to get back to this, to the Source Map Explorer, yeah, it provides great framework for deciding what we are using in the app and how we can optimize it further. And on the other hand side, so we were we had a lot of issues in initial versions of the Angular compiler when it was generating a lot of source code for our components. But over time, in version 4 and in version 6, well, in version 6, there are still not such a major changes, but probably in version 7, there is going to be a major change introducing Ivy. This is going to let us reuse the bundles of our apps much more. So, for example, Rob showed a demonstration of how we can shrink the bundle size of our Hello World tab to 2.8K or 2.7K with Broadly compression. That was pretty impressive.
I know. There were so many people excited about that. I even was talking to like some internal people on the Google teams that aren't on the Angular team, and they were like, "Did you see that demo?"
Yeah, it was pretty amazing. I got really excited as well. And I was thinking, whoa, my Angular app is finally going to disappear. Basically, the browser is going to download it so fast. But when I think about it, most of my bundle is not actually Angular. It is still like some third-party dependencies that I've been using. For example, in our avatar uploads, we have a feature for automatically detecting the face of the user so that we can position properly the cropper. And this face tracking thing, it's about 400K, I think. So yeah, this is something we should definitely load lazily. And these are some decisions which we can make by looking at our application and just deciding what we can postpone and what we can load later.
Yeah, so that's like the next step, right? Is like first we eliminate the things of the libraries, the pieces that we don't need, right? And now we're into the part of going, okay, well, when people start using our apps, like what parts are they hitting? What parts can we defer until they hit later in case they never go to that piece or that sort of thing, right?
Yeah, exactly. And also at the same time, there are a lot of people think that, well, we have tools like service workers and Universal, which are improving our performance a lot. And that's also true. However, with Universal, we can render our app and show it to the user, but that's without JavaScript. The JavaScript being there, it's not interactive, so the user cannot use it. Actually, it can eventually buffer events with Preboot or any other tool, but it's not completely functional. And with service workers, they're also amazing, but they can perform some very advanced caching after the initial application load, which doesn't solve our conversion problem. So yeah.
And the other aspect is the social sharing, right? Discovery and indexing and search, result type of problem that
With Universal, yeah. So Angular, although I guess we mentioned that the runtime performance is cool, and we have these like on push and pure pipes things to take care of it. We have also the network performance where our JavaScript is maybe the most expensive facets that we're transferring over the network. And Ivy is unfortunately not going to completely solve all of our problems. We should just analyze our bundles and decide what we can keep, what we should keep, and what we can get rid of. And service worker are also amazing, but they're going to help us with like every subsequent page visit, so that we can have everything into the cache and they can deliver amazing user experience. But Angular also provides another tool which is, in my opinion, the most powerful one. We can delay the loading of the JavaScript associated with different parts of our application. So we can use lazy loading.
Yeah, let's talk a little bit about that.
This is the part that I'm super excited about.
Are you excited about it, or is it funny? I can't tell by the look on your face. Like, is it exciting or hilarious?
I've decided to expire all emotions, and it's just going to be words. Emotionless, dead words.
Okay.
Just like I type.
It's exciting, haha.
No, it's super exciting to the idea that you can have a really complex application with lots of logic, lots of different areas, but not expect your users to pay the price upfront for getting all those features.
It's a little interesting because it's kind of almost like going back, right? So what I mentioned earlier, which is developing for the web back in the day, where you'd hit this URL, you hit this URL, you get another, HTML page each time you navigate to it. Now with lazy loading, it's almost like we're kind of deferring screens, right? And you're saying, okay, I'm going to go navigate to this order list screen, and that's going to lazy load in, and it's almost like spa version of, I don't know, maybe analogy, I don't know.
Yeah, that's a good analogy. Yeah. It's a version of a traditional web app, of traditional web page or something.
Because I think maybe, I don't know, maybe it's me, but do people kind of think of when they approach lazy loading within Angular, thinking about it in terms of almost like lazy loading features? And so you're kind of almost thinking like this is a feature with some screen view or something that I'm lazy loading in, or are we going further than that?
I guess we can go two different ways here. We can either go on lazy loading per page or lazy loading per component. So component-based lazy loading or page-based lazy loading, so the component-based lazy loading is on lower level of granularity. Basically, we are loading individual components there. Not actually, that's the case completely. That's completely the case for page-based lazy loading. But at least we have defined our split points. They are the individual pages that the router should load lazily. With the component-based lazy loading, what we can do there is, let's say we have a chat box somewhere on the screen. We know that almost nobody uses this chat box, so we can just put a placeholder, something like a remote proxy. That's I guess how you would call it in traditional design pattern terms. And when you click on this chat box, on background, the framework is going to just download the bundle associated with the chat box, and well, it is going to bootstrap the functionality, and you'll be able to interact with the application. So that's component-based lazy loading, and the route-based lazy loading is something that the router can do.
But I think what you're leading to is with the router out of the box, you can basically define, hey, I just want this route to be lazy. If it's requested, go and get it.
Yeah.
But so basically the two options that people are most familiar with is, hey, I've got a route. I want the JavaScript for it. I'm going to download it right up front. No issues. And then the other one is to lazy load it and say, hey, on demand, if I need it later on, if somebody clicks on that particular link, like an admin route or anything else, that it will get that JavaScript at that time. But I think what you're going to lead in to talk about is somewhere in the middle, in between those two.
Yeah, well, the component-based lazy loading is not too popular in Angular. There you can use dynamic ES module imports, where you can download individual components which can be rendered somewhere. Actually, with Angular, I've been using most of the lazy loading of the router. I haven't been using the specific lazy loading strategy where I'm loading individual components on demand, but that's another good alternative for delaying the loading of some features when they're not required.
Right. I was referring to like the preload.
Oh yeah,
the idea of preloading, so that though you could basically tell your application of, hey, yeah, a lot of my users are going to be going to here eventually. So in your downtime, in between the user handling other events, go ahead and download this so it's ready when they need it.
Yeah. That's I was delaying this. That's the exciting thing. So I was delaying it.
Now I want to talk about the exciting thing. See, now I'm going to get emotional.
Right. Yeah. So we can delay the loading of some of the pages. For example, if we have a home page and about page, and the users are usually visiting the home page, and we know that it's not too likely for them to visit the about page, we can just keep the about page bundle on the server and do not load it in the browser. So we can just use load children in case of Angular, and points to the bundle which is about the about bundle. And the users are first going to open home. They're going to see the home page. And when they click on about, the browser is going to send a request to the network, downloads the about bundle, process it, and right after that, just render the about page on the screen. But the important thing here is that we're getting this delay. We're getting a little bit of latency between the user clicking on the about button, for the about page, and the about page being rendered. So that's kind of kind of inconvenient for the user. It can still introduce some additional delays, especially when the user is on mobile network. So
and that goes to your point of that you got to download that JavaScript bundle, so you're waiting for that, and then you got to have that JavaScript execute, right?
Yeah.
And so that's that delay that you're mentioning in terms of lazy loading. And then the other thing I think it does is it puts the onus on a developer to now think like, okay, that could happen. So now do I change my UI around? Do I have loading spinners? What do I need to do to incorporate that as well, right? So not only for the users, but also for the developers and their approach.
Yeah, exactly. And from user perspective, from user experience point of view, we should provide some feedback to the user that something is going on, not the user just waiting for seconds to see the about page, and because they're just going to keep clicking on the button until they give up. So spinner is one idea, which is fine, but still we are not providing. Well, the best possible thing to do is just to immediately render the about page, right? But still, it is still on the server, so how we are going to render it immediately onto the page? So what we can do is to download the bundle. So the user visits the home page, Angular renders the home page, and on background we are downloading the about bundle because we think that the user may eventually go there. So we are just prefetching this asset, which is staying into the browser cache so that it is available there when the user needs it. And yeah.
So essentially, at that point, they're not blocked by hitting the home page, right? So they get the home page experience. It's not blocking. There's just another asynchronous request that happens to prefetch the about page, so they can still interact with that home page. And now, in case they click, it's already there.
Yeah, exactly. Everything is happening on background, so it's not blocking for the user though, and for its experience, for their experience.
So the prefetching is preloading. That's like synonyms.
It's so
sorry, was that no good?
It's no, it's pretty good. It's it's kind of tricky. So the Chrome team introduced this link prefetch and link preload, which have some difference, and we can mention that was actually the next thing that I was going to say. Because from here I was going to go to the preloading strategies of Angular, because the Angular router already has been developed with this in mind, that we may eventually want to preload some of our bundles and put them into the cache or in memory so that they're available for the user when they navigate to other pages.
Hey, I got a quick question that popped in my mind, that a little panic question here before we move on. I don't want to derail it to go too deep in this question, but I do want an answer. If I have my bundle, right, for my home, and I have my bundle for my about that I'm lazy loading, and both of them use some same RxJS operators, are those RxJS operators code going to end up in both bundles?
Probably Mike is the best person to answer here.
It's bad when it's passed to Brocky.
I know. I think the appropriate answer is it depends. That sometimes those will get broken out into a common bundle, but sometimes they will be included in both or multiple, depending upon how you have configuration set up. I believe is the right answer.
That was my developer mode kicking in and going, oh crap, do I need to optimize that? All right.
Yeah,
I think the CLI has logic built in to make the appropriate decision based off of how big those shared pieces of code are, to determine whether or not to break those out separately or to leave them where they were.
There is one more problem with this. If you have two copies of the same third-party dependencies in two bundles, and this dependency is not stateless, this may create serious issues. I was trying to run the universal in a service worker some time back, but that was during Angular alpha maybe or something. So I was having two different copies of Angular, and the providers were different. So it can get a mess, I guess. Yeah, and this is something that we're going to work on in Guess.js as well at some point.
Wait, take a step back. You were trying to render universal, like render the application inside of a service worker, inside of the browser?
Yeah, I was able to achieve a result in the end. Like I was able to do that, but it wasn't too useful.
I was going to say, 'cause, you have two different opposing things. And I mean, running all in the browser is a whole different animal of craziness. But the idea of taking Service Worker, where you can run things online or offline in the browser, and then Universal, which is basically pre-rendering on the server, and why you would want to utilize both of those at the same time is a use case that I don't fully understand.
Yeah, what's up with your crazy experimentation?
At this time, I was working with ngAir mobile team together with Gechev and with Alex. The idea was to generate application shell in the browser and cache it into the service worker. And yeah, we were doing some experiments by using Universal on the server side in order to hint us which can be part of the app shell, and doing some things in the service worker. It should be still somewhere on the mobile toolkit, in the mobile toolkit repository. Yeah, it was pretty fun.
To be clear, as of right now, app shell pre-renders your app shell route at build time is the way the app shell currently works.
Yeah, well, at that time, we were doing that. So the Universal renders something which is with some specific providers which are hinting that you actually want to render an app shell, not the entire application. Our Angular service worker, which is now completely different, sends requests to the server, gets this thing which is supposed to be an app shell. So some things are annotated as part of the app shell, others are not. In the service worker, we're traversing the rendered view, excluding some of the elements, and also making requests to the network in order to download some of the images which are supposed to be part of the app shell, in order to turn them into base64 and inline them into the app shell. And right after that, and it's the same for styles, of course, and after that, putting this thing into the service worker's cache. That was the thing that we ended up working. But anyway, that's not related to the lazy loading strategies.
I'll be right back. I'm going to go take some Advil.
So prefetching strategies.
Yeah, yeah. The Angular router comes in with some preloading strategies for downloading lazy loaded routes, and the only implementation that it comes with by default is the preload all routes. I think that's how it is called, and it preloads all routes. That's what it does. So you set it as values of the preloads config property of the for root, like of the module which you need to include into our main components, like root component. And from there on, it is just going to download all the different chunks which are associated with lazy routes in your application, like completely everything. Which might be good for some smaller applications, but for bigger applications, when you have several thousands of bundles, it definitely doesn't make it's definitely not feasible. It can create a lot of issues, especially on mobile networks.
Which makes sense, because not everything is black and white. You have to find that gray area in the middle. So what do we do?
Yeah, and there are actually two things about it. One of them is that it sends XML requests to the network. It doesn't use preload, prefetch, the meta tags, which are hinting the browser to download something on background with lower priority. And the second one is that it downloads everything. Yeah, and we can come back to what Alice was talking about previously, the preload and prefetch, the difference between these two. So looking at how Chrome implements these things, preload resources are to preload a resource is to download something with that we have higher confidence for it that is going to be used by the current page. And we're prefetching assets which are likely to be visited in future navigations. So I guess preload is something which has higher preloading resources, that we have higher level of confidence that these resources are going to be used compared to prefetching them. At least that's how Chrome thinks about it.
I think we're all kind of letting that sink in.
Yeah, can you say that again? So preloading, you said, has a higher level
we have higher level of confidence that these resources are going to be needed in future. And with prefetching assets, we have lower level of confidence. So assets which we want to prefetch, they're going to be downloaded with lower priority compared to resources which we would want to preload.
Okay, that makes sense.
Yeah.
You're saying this is how Chrome looks at it. Does that mean this is not how you look at it?
I look at it. Yeah, I look at it the same way as Chrome.
Okay.
I'm because I don't think there was like defined previously specified way to look at it, so I'm taking with Chrome.
Gotcha.
Okay,
Yeah.
so if we may not want to do all of it ahead of time, like how do we make the decision of what we're going to do, what we should do?
Yeah, we can. Yeah, so we can provide the custom preloading strategy. That's one of the ways to approach the problem. We can use custom preloading strategy where we are, for example, we have looked at Google Analytics and we see that some pages are being very frequently used. Other pages are not being that frequently used. And we can have a Boolean flag, which says true for pages that would want to preload and false for pages that would not want to preload. By pages, I mean the bundles associated with these pages. So that's a pretty good solution. But it's a binary choice, unfortunately. So we can either preload something or not preload it. So that's one strategy, which I think it's pretty good. And the first issue with it is that it is binary, so we can either preload something or we don't preload it. So we cannot have any other variables such as the network connection of the user or the device that the user is using. This is one of the problems. We cannot make decision based on that whether we would want to preload more bundles or less bundles based on the speed of the user's connection. And the second thing is that we cannot think about, we cannot only prefetch only the bundles which are going to be needed at a given point in the user's navigation. So for example, if the user can go only to about from home, and the user cannot go to, let's say, the page tools, there is no point for us to download tools when we are in home because there is no link to tools at all. And the users have never done such a transition from home to tools. So there is no point for us to download tools at all. So we can delay this until we go to a page which links to tools. And with the preloading strategies, there is no trivial way to do that right now.
So I think I cut out because I don't know if I mentioned this, but I want to touch really quick back on what we were talking about with like this being a binary choice, right? True or false, right? And so we have our own custom strategy and we say these 4 lazy loader routes, they're the ones we want to prefetch. We need to configure that to say true in our strategy. And then that builds, and then our build of our bundle of our code is just kind of hard coded at that point that those are going to be preloaded, right?
Yeah.
And so that's where we're kind of like, okay, we can't really adjust on the fly or anything on that. It's just yes or no.
Yeah.
Now, a little bit more detail on that. So with this custom preload strategy, that's something that the router exposes that you can define when you want to preload a particular route based off of some sort of logic. Is that function executed synchronously or could it return asynchronously? Like, can you have it determine that logic based off of other asynchronous calls? Because it's being executed real time in the browser as your application is running to determine that logic.
Yeah, that's a really good point. Yeah, I think it is asynchronous. It is using observables. So you should be able to send an API request. Yeah, you should be able to send an HTTP request to a service which tells you, should I download this? Should I prefetch this route or not? So depending on the implementation of our preloading strategy, the choice might not be necessarily binary or synchronous. It can be asynchronous and not binary. So imagine we have a service on the backend, which we have an API endpoint on the backend, which tells us what is the confidence level that given page is going to be visited. So in our preloading strategy, we can send requests to this API endpoint and get all the different pages which are likely to be visited at a given point. And after that, the preloading strategy can make a decision based on that, what needs to be prefetched and what not. That's one possible solution that we can go to. The only drawback, I guess, is that we need to send another request to the network, which might not be, well, it depends on the application that we have. It might be a good idea or it might not be.
But through Universal, we could potentially provide some sort of map of that information into that function could use real time in the browser, therefore no additional request. But at the same time, it depends upon how large the map of your application is. Whether or not you want to do that or separate that out into another asynchronous call, weigh the differences between the two.
Yeah, that's actually something what Guess.js does. It behaves like Universal in this sense. So yeah, here comes the universal answer actually. So I've been thinking about these problems some time back, and it turns out that I'm not the only one thinking about them.
Like the three of us are thinking about it now too.
So what happened was that I started working on a solution which can work, which by using Webpack and Google Analytics can decide which pages make sense to be downloaded at a given moment, depending on the user's navigation, depending on the user's state actually in our application. So let me just reflect on this one more time. So basically, by using Google Analytics data, I want to map the individual routes from there, the individual pages from there, to routes in our application, and respectively to bundles. So this mapping is kind of complicated to map routes from Google Analytics to make like pages to actual bundles in JavaScript. And right after that, while the user navigates in the page, decide which bundles we would want to prefetch.
Is this different like per user? Or is it just like analytics for your whole site on average?
Yeah, it can be different per user. That's another thing. We can go even more complicated. But that's a really accurate way to predict the user's behavior. So I wrote an article about this, how we can use static analysis and techniques from the machine learning in order to predict what the user behavior is going to be. And based on the user's navigation behavior, we can pre-download, prefetch some of the bundles. And it turns out that the Chrome team, specifically Adius Mani and Katie Hempinius, were working on this. So yeah, we basically combined forces together with them and with Kyle from Gatsby, and developed Guess.js, which is a set of tools which actually aims this to predict the user behavior, and based on this, provide some conclusion which assets the user may need in future. It actually tries to provide a little bit more, but that's the start. So Guess.js.
So how long ago was this that you did this?
I think I did the initial version of the research in March, and in April and May we compiled all the things that we had under the Guess.js organization. And yeah, currently we have Gatsby plugin. So Gatsby is something like a static site generator with React on top of React. It is already using. It already has Guess.js plugin. Fortunately, Guess.js also works pretty well with Angular, exactly because I've been playing a lot with the compiler, and the compiler can very accurately provide me an idea of how the different routes are defined in the application. So statically, basically, the compiler can look at the route definition and output just a huge array with them, so I can map them to Google Analytics routes. So that was pretty fun, and I have Angular version working.
Woo! That's awesome.
Yeah.
So here's the follow-up question. So with having that map of predictive routes to bundles, have you been able to do any analysis of implementing this on a site to see the accuracy of what you're predicting and whether or not you're preloading the appropriate bundles?
Yeah, it's so it depends on the model that this implements. Currently, we are using Markov chain, which is a kind of a simplified model which has its own huge benefits. It's not too accurate though, so it looks only at your current page, and based on the current page that you have visited, it can decide which pages you're most likely to visit next. So it doesn't consider your navigation behavior previously, your navigation history. And we are looking at recurrent neural networks right now, which is something fun to be looking at. They're very useful for modeling of sequential events, basically. So such as visiting pages or even natural language processing, where you take a look at the sequence of words and you try to make a conclusion what part of the speech this word is, for example. These are all sequences. So that's pretty amazing how this model can work in all these different scenarios only when you need the data to be sequential, right? So that's pretty amazing. And we're looking into this, how this can eventually improve the accuracy even further. I think I added some benchmarks in order to see how accurately we are guessing the next page, or how at least how much more efficient the app is doing. So we are looking at providing more accurate benchmarks, but we don't have anything yet about this.
So you said right now it's using a markup chaining model, but it's might not always use this model?
Yeah, it may use neural network in future.
Okay.
And yeah, it has both approaches have their pros and cons. And we're going to explore the accuracy even further, but for sure it is performing more accurately just compared to just by arbitrary assigning priorities to the individual bundles based on our own feelings.
I feel like this bundle is not that important.
Yeah. That's what I usually do, actually. So
it's probably outperforming my math.random as well.
Yeah.
So,
yeah.
So this is at build time, right?
Yeah. So at build time, we're collecting the routes, getting the data from Google Analytics, and mapping these, basically creating a mapping between these two, and building the model. And this model just accepts a page as an input and receives the possible navigations as an output by assigning probability to each one of them. And right after that, we're taking this and putting it into the main bundle of the application. And from there, the Guess.js runtime is asking on each page navigation the model what other pages are going to be likely to be visited next. And based on this list, we're just prefetching the most likely to be visited bundles to be required. Yeah.
Okay, and so then this is something that we would add into our build pipeline, not necessarily something that we would, update our code base and commit to the code changes or anything like that, right?
Yeah, that's what I love most about it, actually. So yeah,
I have one question. So I start off and I'm at the root of the application, and we go ahead and we do this predictive analysis to see what other routes to preload. And say I'm at the home page, and then by chance I go to another route that was preloaded. And from there, because I've got this really big site that's totally arbitrary, does nothing at this point, that has all these other routes that you could potentially navigate to. Are you then able to further do additional analysis to say, hey, I'm at this route, where might I go to preload and go that to be able to further explore out that tree of preloading rather than just an initial route transformation?
Yeah. At any point, at any page, you know where the user is likely to go next. At any page, unless you don't have Google Analytics data. In such case, there is nothing we can do.
Then you fall back to my math.random. But
yeah. Yeah. Or personal feelings. One of these two.
Yes.
I just wanted to make sure that it's not just a one-time upfront loading feature of, hey, my application loads and bootstraps itself and the router initializes to say, hey, go ahead and preload a few things. But it can go further, that if you have a dashboard that goes to a subpage that then goes to possibly 3 different subpages, that it will preload 1 or 2 of those to be able to essentially preload out the entire tree in your life cycle of the entire application versus just an initial load.
Yeah, that's what it does. It has information on each individual state in the application page. Yeah, it's what it does right now. And also, so there are 2 big issues with this. One of them is to not perform overfetching. So overfetching is going to be a problem specifically on mobile networks if you fetch too much more data compared to what you need. And this is the problem with the preload all modules or preload all route strategy. And also there is one Webpack plugin for preloading all the assets that you have as part of our production build. It just puts all the different link preload tags in your head, and it downloads completely everything, which can be kind of slow. With Guess.js, we are sure that we are preloading stuff depending on the threshold that we have set, and we are sure that we are not preloading too much stuff because we are still ignoring some things. And we are also sure that we are doing all of this in some reasonable, taking some reasonable chances for the user to go somewhere. Because, well, we are considering real data that we have from Google Analytics, and we are cutting the pages which are not likely to be visited, cutting the pages, yeah, and that's it. And we're preloading everything else.
So this is all decided like ahead of time, and there's like a big fat map that's like, if they go here, then this. If they go here, then this. It's not like, as I go here, then behind the scenes somewhere, this is generating a new map, right?
Yeah, it's something like that. It's predefined map. And the map, yeah, that's another problem, because we don't want to introduce 1 megabyte of JavaScript only in order to predict where you're going to go next and prefetch your...
I was going to say, that sounds insane. What is the answer here?
yeah, and prefetch like your 5K. There is a compression of this Markov chain that currently I'm doing. So it is, in the end, it is not more than like several. For example, if you have 100 pages, it is going to contain like several hundreds of numbers, which is not too big in order to create this mapping. Each page is a string, but internally with Get.js, we're doing some compression in order to shrink this matrix even further. But also, that's one of the advantages of the Markov chain, because the Markov chain is just one matrix, which on rows in the columns has the individual pages, and each individual cell in this matrix shows the probability for the user to go from one page to another. So it's that simple, the Markov chain.
But I'm assuming you must think there's a more accurate way with the neural network. Otherwise, why give up the markup chain?
Yeah, exactly. So with the neural network, the things there are 2 main issues. Actually, more than 2 main issues. Actually, there are much more. But maybe the biggest concerns there are that the model can be too big. So the entire TensorFlow, if we want to include the entire TensorFlow in our application, for example, that's like 400K for TensorFlow.js, which is kind of too big. And we also have our model that we need to put there. We are not sure how well TensorFlow is going to perform on mobile, because it uses some GPU acceleration by using WebGL. And the third thing is how long it is going to take to train this model, because at build time, like the ahead of time computation is going to be very fast with Ivy, but well, we don't want to train a neural network for like half an hour and in order to get your bundle prepared. So probably it's not going to take half an hour. Probably it's going to take less than a minute. But well, yeah, with Markov chain, it's instant.
I don't know. I would give up half an hour if it was like this super awesome, like very well, like if it worked really well for users, because that's half an hour of my time, not their time.
Oh yeah,
The mistakes of whoops, I didn't preload that. So I don't know. would almost vote for that, but at the same time, I guess there's no way that would be feasible. Every time you want to build, it would take that 30 minutes.
Yeah, it's not going to be 30 minutes. So I'm saying this is an upper boundary that we should never reach.
Okay.
So what's the threshold? Because I mean, there's a lot that goes into this to make these or to build this mapping out to decide whether or not you want to preload an additional bundle or not. But if my application is just, hey, here's about me and here's a contact me, and it's just 2 pages, I don't want that to put that type of investment in an application.
You're saying like
But
a minimum bigness?
Yeah, that's what I'm getting to. I mean, but if you have this 100-page application with 100 routes or hundreds of routes or thousands of routes, yes, then it may make sense. But when do you think you may hit that tipping point of saying, hey, maybe this is something I want to consider with my application?
Yeah, there are a couple of questions. So the first one is from how many pages you can go from a given page. If from any given page you can only go to a single other page, for example, you're in a wizard, it doesn't really make sense to build such thing. So this makes a lot of sense to be used for pages like Wikipedia, where you have a lot of possible transitions from given page. Also, another thing is how many pages you have. Of course, if you have too many pages, it makes sense. If you have 3 pages, well, it still doesn't. Also, the bundle size is important, and the routing, the nesting of the routes is very important as well. We didn't talk about this previously, but nested routes can create. So the idea of Guess.js is that it should not only do predictive prefetching, it should also think about your bundles and the most efficient way for them to be formed. You should take a look at all the bundles, all the different JavaScript files, all of their dependencies, and Guess.js should be able to decide how it should cluster the individual files, how it should combine them in a way which is most efficient, taking a look at the user behavior and also the bundle size. This sounds a little bit well. It's actually not too complicated. It's the algorithm is it's not too complicated. Well, we're just looking at the bundle size and the possible navigations, and from there we're making some conclusions how a given bundle should be clustered together in order to be combined into a single bundle and do not cost us an additional request. And we're also deciding which pages should be prefetched at a given point. So it's not too bad, not too complicated, but it is going to save so much time to the user, and it is going to make decisions which are actually based on data, which is the most important thing. So our applications are going to get smarter and faster. That's why I'm excited about this project.
Hey, it's got me thinking about this build pipeline scenario and stuff like that. Is it going to introduce something new where, let's say I've got my code base that I haven't added any features to or changed for 3 months, right? It's stable. Yet my usability of the app, these metrics, popular. Like, in order to take advantage of that with this pipeline, do I just need to like regularly have a build and deploy process, even though I didn't change any of my code, in order to pick that up?
Yeah. For example, for the past few weeks, every 2 weeks, even without having changed your code base, you can rebuild your application in order to provide the most accurate bundle configuration and like prefetching strategy for your users, because they change their behavior over time. Yeah, that's a lot of fun. So your build is getting adaptive.
That is cool.
So then I guess the next tool would be like, how to identify that like I've got a new smart build on my deployed to my production, right? Like what version, when does that change? What version is it? Because it's not actually the version of the code base built, right? It's this additional stuff.
Yeah.
Which I guess is kind of the same concept of like your data changes over time, right? Your app may stay the same, but maybe the backend data changes. And so that changes like the feel of your app. You know, say you had a menu system in your app that was driven from data, right? And you change that to be 4 links instead of 5. Then your app has changed, but your deployed code's not changed. So I guess it's still kind of that same vein, right?
Yeah. Yeah, and since a lot is happening behind the hood here, although in the end the source code is like 2,000 lines of code. It's like not enormous code base. It's pretty small. It's going to grow over time, but at least the base is pretty small. We want to automate the process also of this thing a lot, because you don't want to rebuild your application every week and go through a lot of pain in order to do that and sacrifice your weekends or Netflix or whatever. We would want to just press a button. We download the data from Google Analytics, and after that, build a model, and and that's it. And plug this thing into the main bundle of the Angular CLI app. So the only configuration that currently needs to be provided for an Angular application is just Google Analytics view ID, and that's it. So you just take the Guess plugin, you place it into the Webpack config, you provide the Google Analytics view ID, and that's it. The Guess plugin is going to ask you whether you provide read-only permissions to your Google Analytics data. You can disagree if you don't want to. If you agree, we're going to fetch this data, build the model, plug it into the main bundle, and introduce a small runtime which tracks where you are at a given point and prefetches the pages which are likely to be visited. So that's the entire process.
Very cool. And so that's something that, like you mentioned, you got to configure Webpack in order to do that, right? So like if I have an existing Angular CLI project, what's my road to get there on that?
So with Angular CLI 1.7, you were able to eject the app and plug this into the Webpack config. With Angular CLI version 6, you cannot eject your app anymore. You can. What I saw is that there was Manfred built a tool which allows you to extend your Angular CLI build. I haven't looked at it yet, so I cannot confirm that this is a new way to achieve the same results with the newer version of the CLI. Probably Mike will be able to help and confirm what is the best way to include one additional plugin in your Webpack configuration.
That's to be determined. The idea of ejecting or something similar will be coming in the not too distant future. I'm also just a day or so removed from getting back from vacation, so my information may not be accurate. So I'll just caveat and put a little asterisk next to my face or something in the video. But as of right now, I don't believe there is a way with version 6 to do that, and I'm not familiar with the piece that Manfred built. I know that he worked on something using for elements, but that's completely different than this. So
okay, yeah. So maybe
I'm not sure.
Yeah, maybe there is no way to achieve this with Angular version 6.
However, if you didn't want to do it as part of your build chain, but make an additional API call out to get that additional information to make those decisions, you can certainly do that.
Yeah, you can. Yeah, you can do that even right. So Get.js on top of on top of this inversion of control thing that it does, where it includes everything in your bundle and you don't have to touch anything, you can use an API. So it exposes one function called guess. You pass and you invoke guess, and guess just guesses. That's it. It just guesses where you're going to go next. So in your preloading strategy, what you can do is just invoke guess. Guess is going to return the number of routes that you can visit next. And that's it. You can just download only these routes and nothing else.
Very cool. All right, well, we're at the top of the hour. Anything else we want to add here before we wrap up?
It's a pretty exciting project. There are a lot of things, but I guess we can stop here.
We can certainly have another episode if you want to do that. Really,
after we have the chunk clustering chunks together in order to make sure that we don't send redundant HTTP requests, that's going to be a huge win as well. So that's going to be a good milestone.
Very cool. All right, so where can people go to start learning more about this and playing with it?
So we'll be working on the documentation in near future. Currently, they can go to Guess.js, so github.com/guess-js-guess. There is already a lot of there are already a lot of readmes there, which also show sample projects which are using the tool. So yeah, I think the information there should be a good start, and from there on, we're going to build some more advanced documentation and a documentation website which uses Guess.js internally in order to dogfood the work.
Cool. And then you have some posts on your blog, right, that cover some of the stuff?
Oh yeah. So the implementation details can be found into one title with a lot of buzzwords. It's machine learning, machine learning driven bundling, the future of JavaScript tooling. A lot of buzzwords. It's very optimistic also. And an article for getting started with Guess.js can be also found on my GitHub. It's introducing Guess.js, a toolkit for enabling data-driven user experience on the web. And I'm going to provide these links in the document as well.
Nice, nice. Well, that's a lot of interesting stuff to digest, right, and to take in. Very, very cool. Appreciate it a lot. All right, do we have any picks? Anybody want to do any picks before we wrap up? Anything you want to shout out? Mike's nodding his head. You want to go first, Mike?
I got two. My first one is actually very new. It's actually from today's episode. Minko was explaining something, and he said, and he wasn't sure if he explained it well, and said he needed to refactor that. So to be able to real-time refactor your thoughts to explain something, I thought was absolutely brilliant. So if I can think of a way to better explain something, I like that, to use the word refactor rather than to refine an explanation. I like that. And the other one that I have is just vacations or downtime. Take advantage of them. Your company or whoever you work for provides you with vacation time. Utilize it, and utilize it well. Get away from your computer, do something else, and come back refreshed.
Nice. Good picks. Good picks.
Thanks.
Anybody else? Alyssa, do you have anything today?
No, I'm the pickless
right.
wonder.
You should
Minko, anything
refactor
else you
that.
want to throw out there?
Yeah, I have one pick. It's something that I'm actually going to read more about, because it's not something that I totally understand yet, but I'll definitely encourage people to look at it and explore the area. So Eric Meyer, he's currently director in engineering in Facebook, and he basically built RX, not RxJS, but like RX, a reactive extension, and he worked on the monads in Haskell and worked on Link in .NET. Like, he's kind of a legend. So he tweeted about one talk recently where basically the speaker says how deep learning is nothing more than just functional programming on top of calculus, not lambda calculus, but like calculus. So that's very, very mind-blowing thing. It takes a lot of time to digest. I still haven't digested completely yet. So, but it's really fun, really cool one.
Nice. Nice. All right. Well, Minko, as always, thanks a lot for coming on, sharing your time. We all really appreciate it. Thank you.
Yeah, thank you for having me.
For sure. All right. That's a wrap. Have a good one, everyone. See ya.